All right, well, we are in Orlando at the 2023 ARA show, and I am joined by Dan Cook from Southwest JCB. Welcome.
Thanks. Good to see you again and be with you again, Mark.
In the case of someone that's looking to acquire one of these machines, they're used to buying a diesel machine, being able to have maybe a fuel tank, and then pump diesel into the machine and then operate. Let's say I buy one of these machines, like what do I need on my job site to operate one of these hydrogen-powered machines?
So you do have to have a source of hydrogen, and one of the areas that the hydrogen economy has to continue to evolve in is the supply chain and the distribution networks. Hydrogen is typically an industrial gas that's consumed at an institutional place like a refinery or a pharmaceutical plant or some place that doesn't move around. In a construction site, when the job is done, everybody packs up and goes to the next place. So today, as hydrogen becomes commercially available, the fuel Bowser that JCB has developed will handle 16 tanks of hydrogen for either the backhoe or the telehandler. And from the entrance of the job site, this off-road Bowser is designed to take the fuel to the machine. The hydrogen economy, as it continues to mature and as it continues to develop its distribution and supply chain, that Bowser would be filled, call it at the front of the job site, to then drive into behind the fence and into the job site to deliver that fuel in the last mile segment of the fuel's journey to the machine.
So it definitely still needs to be that distribution network that needs to be set up, because like if you went to any job site today and you spoke about hydrogen, most of them are going to be pretty confused on how they're even going to get that fuel cell to the job site. So it's an important factor for education as well.
Absolutely it is. And the product's not commercially available today. It's still in its research and development phase. It's still in the overall what else has to happen to it to become a viable alternative to diesel. However, if you look at in 2021, I believe the statistic, if you look at in 2021, there were under 10 hydrogen-centric projects in the UK, and today there's north of 40 being developed. Similarly, in the US in 2020, there were 40 hydrogen stations around the country, and today in North America, that's estimated to be pushing over 200. So the opportunity for hydrogen to become a viable fuel source, I think it becomes a question of chicken or the egg. Do you need to have push-through demand from the hydrogen supply chain, bringing it closer and closer to where it can be consumed? Or do you need to have pull-through demand by creating the demand or creating the appetite for it through things like our telehandler and our backhoe and the fuel Bowser to where it pulls the hydrogen infrastructure closer and closer to those machines?
And then on the hydrogen itself, so it's obviously in an area that's good for the environment, but there is different types of hydrogen, which I think is important to cover. So can you talk about the different types of hydrogen?
Yeah, this is a pretty cool topic, in my opinion, when you really zoom out away from the construction equipment, because the benefit that hydrogen has over any fossil fuel is no carbon in, so therefore there's no carbon out. There is zero carbon emissions with hydrogen as a fuel source. So when you really start to look at the hydrogen economy and where does hydrogen come from, the most ideal hydrogen on the color spectrum is called green hydrogen. And green hydrogen is simply the splitting of water, H2O, into its core elements, oxygen and hydrogen. And with green hydrogen, you do that through a process called electrolysis. You use an electrolyzer. And the byproduct of that is you release oxygen, which is a completely harmless gas. Through that process, though, there are precious metals that are used in these electrolyzers, and you have to have desalinated, deionized, very, very pure water, and it's just very expensive to bring those raw materials to bear in that electrolyzer. As published in February of 2023, researchers and engineers in the chemical engineering department at the University of Adelaide, an Australian university, they have discovered a way to use seawater or salt water and non-precious metals inside of these electrolyzers. Specifically, cobalt oxide and chromium oxide are the two metals that they use to generate green hydrogen out of salt water. And that's a huge step forward. Salt water is probably the most abundant resource, if you think about it, in the world, and within water is an almost infinite supply of hydrogen. Salt water can be found along every country that has a coastline, and it's very efficient to bring it to the source of the. It's very efficient to bring it to an electrolyzer because it is so abundant across the world. Differently than having to use very pure, deionized, desalinated water with precious metal electrolyzers, this now puts hydrogen, and not just any hydrogen, but green hydrogen, within reach once that technology is scaled. A more common way that we can find hydrogen, a more common way that we can source hydrogen is called gray hydrogen. And within the natural gas refining space, you can strip hydrogen out of a natural gas fuel source, and the byproduct is CO2. So now we're back to carbon dioxide. So while hydrogen at the tailpipe is a very clean emitter, when it is deemed and classified as gray hydrogen, there's a significant carbon footprint that's associated with it. Now, you can sequester that carbon dioxide emission, and when you do, that gray hydrogen can now be classified as blue hydrogen, but there's still an economy of scale that goes against the commercial viability of hydrogen, because that's a very expensive process to capture that carbon and inject it into the earth, as the oil and gas industry does today. And it makes hydrogen commercially out of reach at today's commodity prices. There's other colors of hydrogen. It just depends on where the electricity for the electrolysis process comes from. You have yellow hydrogen, which is tied to nuclear energy. And there's a couple of other colors that are become less and less appealing from a green footprint standpoint, because they cost more energy, they cost more dollars than what you get out of it in terms of equivalent energy.
It's amazing. Sounds like we'll have to go to Adelaide to do a podcast.
Well, I think it would be good as the hydrogen economy takes off and as the technology becomes scalable and within reach and commercially viable for the hydrogen economy. Understanding how we can get hydrogen through their processes and others, it would be very valuable for the industry to understand the hydrogen supply chain.
Okay, amazing. Love it. Well, Dan, thank you for coming on the Rental Journal podcast again.
Mark, thank you so much for having me. It's wonderful to see you here at ARA in Orlando, and I'm looking forward to seeing what the show has in store for us both.